A typical modern JavaScript application contains a lot of files and JavaScript modules, especially because it makes it easier for developers to work on a large application by dividing it into smaller parts. And it also gives them the ability to reuse code from one file to another. On top of that, those modern JavaScript applications use a process called bundling, which organize and merge all your JavaScript modules, HTML, CSS, and everything else in between together in a single file called bundle. This bundle is then included in the HTML file to load the entire application at once. Note that bundling is done using a tool called a module bundler, like Webpack, which is already set up out of the box with Create React App, Next.js, or Gatsby. So you don't have to worry about it and you don't have to set it up yourself. One major issue with this bundling process is that as all your code is bundled into one file, it can become really large as your application grows, especially if you include many third-party libraries into your app. Therefore, a huge bundle can lead to performance issues as the initial load time of your application increases. To solve this issue, we can use a technique called code splitting to split our bundle into several bundles called chunks, which can then be loaded on demand. So we only load the code that the user currently needs. This technique can significantly improve the performance of your application as we no longer have to download everything at once during the initial load, but we just download what is necessary. In other words, we don't download the code until the user needs it. For example, if the user is visiting the homepage of our application and is already registered, it does not make sense to download all the code of the registration logic as it will never use it during his visit. Okay, but how do we actually do that? By using dynamic import, which is a new function-like form of import that unlocks new capabilities compared to static import, such as importing a module on demand. Instead of using the simple and strict syntax of import, where the module path must be a primitive string and does not allow to import conditionally or at runtime, we can call anywhere in our code the import expression as a function. When called this way, it returns a promise that resolves into a module object that contains all its exports. And when Webpack, the module bundler, comes across the syntax, it automatically starts code splitting the application. For example, this makes it easy to load functionalities onto a page based on user action or lazy load modules upon navigation. Now, if you'd like to use that in our React and React Router applications, we will need React.lazy, which lets us render a dynamic import as a regular component. So, instead of importing a component like this, as usual, we'll call React.lazy and pass in a function that returns a promise from our dynamic import with the component we'd like to lazy load. By importing our component this way, we're actually doing two things. First, with the dynamic import, we're telling the module bundler to split our code and only load our component when needed. Or in other words, when our component is first rendered. And then with React.lazy, we're taking our dynamic import and exporting it into a lazy React component we could render as with any other React component. Let's now take a look at some code so we can see how to set up route-based code splitting into our app using React Router and React.lazy. So here we have our React application with a few React components representing the pages of our application: home, blog, about, and not found for the 404 page. And down below, we have our routes to map the user's current location to those components. So the idea is to split the code of this React application so that we don't load all the React components at once during the initial load, but we wait until the user visits the corresponding route. In other words, if the current user does not visit the blogs page, he should not have to download all of the code for rendering all the blog posts. Same thing with the about page. If it does not visit it, the user should not have to download the about components code until he visits the /about URL. To do so, we are going to use dynamic imports and React.lazy. But before we do that, let's run npm run build to create a production build of our application and see all the different bundles generated by the module bundler to compare it with what we will get after code splitting the application. Once it is done generating the production build, we can see that it has generated a few JavaScript and CSS files, or chunks, inside the build/static folder. Those files are actually the bundles where all our React application code and vendors code live, which are then loaded into the browser all at once. As you will see, after splitting our application, we will have a lot more chunks that could then be loaded on demand dynamically. So let's go ahead and code split our application. So instead of importing our home component statically at the top, we use React.lazy and passing a function that then uses dynamic import. And we can do the same thing with all the React components that are used to render the pages of our application. Now, if I save this, you see that we have an error saying that a React component suspended while rendering, but no fallback UI was specified. This is because our lazy React component should be rendered inside a suspense component provided by the React library to show some fallback content while the user is waiting for the component to load. So here we can wrap all our routes inside a suspense component, set the fallback prop, and pass it the UI we like to render while the user is waiting for the page. And here I've used only one suspense component and wrap everything inside it, but you can actually use several suspense, one per lazy component, for example. Now, if I refresh my browser, everything is working fine, and I can visit all the pages of my application just like before. Okay, so let's look at the production build now that we have split our application based on its routes. If I run npm run build again, you can see that we have way more chunks than before. We actually have one additional chunk per lazy component. So here we have 4 more chunks. It's hard to tell from their names which chunks correspond to which component. So let's use Webpack magic comments inside our dynamic import to set the name of our chunks. So just before the module path, we can add a comment with Webpack chunk name to set the name of this dynamic import that Webpack will use as the name for the corresponding check. And we can do that for all dynamic imports. Now, if we go back to our terminal and run the production build once again, we can clearly see that our application has been split properly with one chunk for each of our routes.